Day 61, illustration number 3. We have here basically a volcano, and deep underneath a volcano we might have this large area where we have liquid magma underneath. That's called a magma chamber. And I want you to write the word magma 3 times here. Remember that magma is when we have the liquid underneath the surface. So down here at the bottom, your last magma, your bottom magma, I want you to put inside. In other words, it is internal to the earth. And so when this magma cools, it is going to cool and form intrusive igneous rocks. So cool next to some arrows here, and that makes intrusive igneous rock. The liquid magma will cool and form intrusive igneous rocks. We can remember it's intrusive because magma is on the inside of the earth, the internal part of the earth. And all liquid solidifies into igneous rock. Now, this magma is going to cool slowly. So on the top magma that you wrote, please put cools slowly. It cools slowly because it's underneath the dirt and stuff, and the dirt acts like insulation, and that prevents the heat of the magma from escaping very well, and so the magma cools very slowly. And what that results in is very large crystals that can form before it's solid. So on the sides of this magma chamber, I want you to put large squares. These represent the large crystals that form as it solidifies. And it'll solidify on the outside first, just like we are showing, and gradually solidify towards the center. So, magma on the inside of the earth will cool to form intrusive igneous rock with large crystals. When this liquid is forced out of the volcano, the liquid is the exact same stuff, but we just change its name to represent the fact that it's now on the outside of the earth. And so now it's called lava. Would you please write lava next to each one of these arrows as it shoots out of the volcano. Over here on the left, we'll write down that this is lava on the outside. Up here in the second arrow, it's lava. It is external to the earth. On the next one, the lava has exited the earth. I write down all those words because I want you to know that when it flows out, it forms extrusive igneous rock. Extrusive igneous rock as it flows out of the volcano and solidifies. So on the side here, write extrusive igneous rock. On the other side, we're also going to have the lava flowing down. And we're going to write some stuff in this. We're going to write that as the lava flows and it's in contact with the air, it cools quickly. And so we have small crystals. If this lava was flowing under the ocean or into some other kind of water, it might cool so quickly that virtually no crystals form at all and it looks like glass. But to represent the fact that it's small crystals, I want you to write very small rectangles on the outside of this diagram. Make these squares much smaller than we did before with the magma. And these crystals would form on the outside like this at first, and then gradually work their way into the deeper parts of the lava as it cools. So remember that this kind of igneous rock is called an extrusive igneous rock. The extrusive happens after the lava has exited the ground. It's on the external parts of the earth. Extrusive igneous rock. Okay, now in this space down here, we're going to talk about metamorphic rock. Along the sides of this magma chamber, we might have other kinds of rock, perhaps sedimentary rock, and it's going to get heated up by this magma a lot. If it gets over 200 degrees Celsius, it might form it might heat up the rocks enough to change the form of their structure. So to represent that, what I want you to do is I want you to draw X's going along the magma chamber here. This represents areas where the rock has heated up and is now changing form. And we're going to label that off to the side here. Heat from the magma changes rocks to make metamorphic rock. Pressure can also change a rock to a metamorphic rock as well. And that is the end of illustration 3.